Before I dive into unmounting this flyback, I wanted to settle something. In the rider's service info, they specify that this cap is paper rated for 600 volts. Well, the only markings on this were Elmenco, and we got 3 red dots, so 2 plus 2 zeros, 2200 picofarads. Although the schematic actually shows 0.002 or just 2000. But I'm pretty sure this is the original. And in my other 810 set, the restored one, similar looking cap. Well, I know that sometimes these can be paper inside, and I got a suggestion that they might be. So, decided to find out for sure. I took a chisel and a hammer and popped it open, and you know what? It's mica. Those are sheets of mica with foil in between. That is a silver mica capacitor for sure. What's really weird about this is there aren't any other dots filled in. Normally there would be one for the voltage rating, and I know that some companies like Mica Mold, if there was a white dot in the corner, that would indicate it was paper. I know in the Motorola VT71s, that's how you can tell. Also, typically there'd be maybe a tolerance or temperature coefficient or something, but there'd be some other markings than just 3 red dots. I have both chassis up on the workbench now so I can compare them side by side. So, the flybacks certainly do look the same, so I don't doubt that they are identical electrically. The only appearance difference, I suppose, is that this has a red frame and the other one doesn't. But there's something else that's different. If you recall an earlier video, I was trying to find this resistor in the other set. It's right across this coil, which I believe is linearity. One of these is width and one of these is linearity. I don't recall which is which. Well, there's supposed to be a resistor across this, I believe, that dampens it, or something to that effect. Well, I couldn't find it over here, but now that I've seen that one, which I'm sure is the original, there are no lugs here. It turns out the lugs are actually on the other end, so I think this is a replacement. Would also explain some of this crudeness in the wiring. As if you see, the wiring here is all neatly dressed. Everything is the right length. But if you look over here, we got this wire sticking out that's too long, and the insulation on these doesn't look so hot. So I think this whole area has been worked on. So what I'm thinking of doing is transplanting this coil and resistor onto that set, and the flyback as well. Now originally I was talking about transplanting the wiring as well, and I'd like to, but that's going to be a lot of work. I want to because I like this insulation, but I think at least just to see if it works, I'll just undo the connections on the lugs here and unmount the flyback and transport it over. That's a lot easier to do than to try to go underneath the chassis and trace out the wiring and undo the leads and pull all this stuff out. And I'll have to undo the high voltage socket, unfortunately. It's not so easy to undo. Well, I mean, you kind of have to. The wiring goes through on these little spacer things and goes around, so you really have to unsolder it from the high voltage socket, so I'll just be careful when I do that. Well, you may have also noticed that there are a couple mica caps here. Well, they were on this one as well. I just took them off while I was troubleshooting because these are not on the schematic. And these sure don't look original. But as I discovered when I removed these, the width shrunk quite a bit, by like 30%. So that's probably why they were added here as well. It just seems so curious that in both sets, the same modification was made, obviously with different type capacitors, and the values might be a bit different. But I really doubt this was done in the factory. And I can't imagine that, like this one, without it, the width shrunk by 30–40%. It was very noticeable. So if these weren't done in the factory, how could these have left the factory with the width being that deficient? I don't know, very puzzling. But, whatever. So I will remove this coil, and let's fly back and swap the other two over. I've been spending some time comparing the two flybacks, the way they were wired into the chassis, and the schematic, and it's starting to make some sense. The reason it's so confusing is that these do not match the schematic. What I mean by that is there are more lugs on here and more wires going to them than there should be, according to the schematic. A few other things I noticed is that there's slight difference in the part number. This says 77J1. This is 77J1, and there's a 2 stamped onto it. Physically, they look to be darn near identical other than the red paint on the core, but there might be some slight difference in the windings. Number of turns, something like that, I don't know. Also, just trying to be kind of helpful, there is stuff stamped on here, like this says SEC.TAP. This says SEC.HOT. Hard to read, so I translated all that and made this diagram. So these circles here, 1, 2, 3, 4, 5, 6, 7, correspond to the 7 lugs on the back of the flyback. So I wanted to match those up to what's on the schematic. Now, if you look on the schematic, we have a total of 4 coils on here. 1 filament for the high voltage tube. That's just a loop of wire here, a piece of cake. Another, this guy, the one that says 809T 230 ohm, it means 809 turns, 230 ohms resistance. That's the high voltage winding. That is this guy and this lug here. Okay, got that. We got this guy, 616T, 38 ohms. That means 606 turns, 38 ohms. And that is this horizontal output tube plate cap and that lug. Okay, great. That just leaves this side. Well, I guess we can call the secondary, that's what drives the yoke. So there should be 2 lugs left. But what do we have? 1, 2, 3, 4. We got 4 lugs, but only supposed to be 2 connections. Well, one of them's unused. Okay. Well, why do we have 3 others? Well, let's see how they're labeled. One says B plus SEC. Seems to be pretty clear that means B plus on the secondary. And if we look back on that secondary, this is where it says F red dot, that goes right to B plus. Okay, great. That must be that lug, right? Okay. What about the other 3? Well, with everything disconnected, I could use an ohm meter and ohm it out. And it turns out that it seems to be one big secondary winding with 2 taps on it. So these are the 2 outside, the B plus SEC and the SEC HOT. So it's B plus secondary and secondary. Normally HOT means horizontal output tube, but horizontal output tube drives the primary, not the secondary. So I'm not sure what that means. It's not used. And then the other 2 are taps. This tap, which says SEC tap, secondary tap, I guess, goes to the damper tube and the yoke. So that is this line right here. Pins 4 and 6 in the damping tube, and then it goes up to this resistor and capacitor, filter, and up to the horizontal yoke. Okay, great. Well, that's also supposed to connect this 125 ohm coil, which is the width or horizontal size. It doesn't. That connects to this tap over here, which has no label on it. Why? I don't know. And that's the 11 ohm section. That's what they show in the schematic as 11 ohms. So I looked through every source I could find of the schematic for this set. Production run changes, service notes. No mention anywhere about there being multiple taps in this flyback and the width coil and the yoke not being connected to the same point. According to the schematic, this damper and yoke should be connected here, and this stuff doesn't even exist. Now we've also got these two mica caps that are rated to both flybacks. I just took it off of this one. Turns out that is connected between this width coil tap and the primary winding, which seems a little odd. In particular, that's the flyback winding. It's not the cap side, so it's this bottom side that has the two 27 kilo ohm resistors going to the screen and over to the horizontal linearity coil. So, whatever. The fact that both of them were wired this way makes me think that's how I should wire them up. It also makes me curious. When I took out this cap, the width shrunk considerably. Well, what if I leave that cap out and I attach this damper yoke to a different point, either up here or over here? I don't know. I'm not crazy about trying that because I don't want to damage anything, but I do find that curious. I would think you would attach to different points, or they would have multiple taps to do impedance matching. That's the whole point of this. This is impedance matching for driving the yoke. And why this is going to nothing, I'm not sure. And there's a fair bit of resistance here, so there's quite a few turns of wire in there, more than 11 ohms, and it's just not used. So whatever. So what I'm doing now is I decided I am going to transplant that big, thick, insulated wiring from my new parts chassis to this chassis and wire it up and dress the leads exactly the way they were on this set. So I've already taken out, for example, there's one bit of wire, and I've transplanted this nice thick bit of wire here. That's what goes to this tap right here on the flyback. So I've got two more wires to transplant, and then I will, for now, I'm going to go with the yoke that came with this chassis and see how that works out. Or did I say yoke? I meant to say flyback. See how things go. If they don't show any improvement, or well, we'll just see what happens. We'll go from there. I still haven't found the problem, but I can tell you a lot of things that it's not. Swapping out the linearity coil had no effect. I then replaced the entire flyback. This is the flyback from the second set, the salvage set. And exactly the same problem. No difference. Also, while I had both flybacks out, I not only tested that high voltage secondary, but I also checked the other secondary winding that drives the yoke. They both tested great. Both flybacks tested great. Not the same as each other, though, but both tested good. So I am now going to turn my attention away from this stuff and check out the yoke next. Before I tried testing the yoke, I noticed I had a little pile of tubes that came out of this set I just picked up. And I remembered that I had gotten some odd voltages on the damper tube. Now I had tested the damper tube and swapped it out with several others, and they all tested fine. Swapping it out made no difference. But I don't know why I thought, what the heck, I'm going to pop in the damper tube out of the set that I just picked up and see what happens. Well, check this out. right away, bright sharp picture. Now, it's not perfect. This is with the brightness cranked up all the way. And when I measure it, I get about 7,000 volts. It should be 9,000. So, hasn't completely cured the problem, but it's a lot better than it was. Now, of course, I'm a little irritated by this because it could mean that this flyback is just fine. I'm kind of inclined to try popping this one back in. When I put this flyback in, I kind of temporarily tack stuff in place, so it'd be fairly easy to get out of here. So I'm wondering if I use this damper tube with that flyback, maybe I'll get my 9,000 volts. I'm also ticked off that these dampers test just fine in my tube tester. So now, can I no longer trust it when I'm testing damper tubes? I really have to try swapping them out in sets. I'm also curious to try popping these into a set like one of my Admirals that I recently restored that I know works just fine and uses the same damper tube, and see how these tubes work in those sets. And I want to try testing this tube too and see what my tester has to say about it. Now, the other flyback also gives me 7,000 volts. It makes me wonder if these mica caps were tacked onto the flyback not just to increase the width, but maybe boosted the high voltage as well. I've already tried adjusting the drive control in the back. Didn't make any difference. I guess another possibility is maybe this damper tube still wasn't as good as it could be, and I should go dig up some more and try swapping it out with those. Here's another little experiment. I figured, hey, if this grungy old tube worked great, why don't I take the high voltage rectifier and horizontal output tube from that grungy chassis as well and pop them in here and see how they work. Well, check this out. Not as good. Picture's bloomed a bit and it's out of focus. So I'm thinking maybe these sets are really touchy to this trio of tubes. So I'm going to do a little more swapping, and maybe I can find the best combination of these three tubes and finally get that high voltage up to where it should be. Check this out. This is the original horizontal output tube and high voltage rectifier I was using when I first started restoring this set a couple weeks ago. With those two tubes, it's absolutely horrible. That's kind of weird too. I'm adjusting the brightness control. And when I go to the extreme on the brightness control, the picture's just all bloomed out. But if I cut back a little, it gets sharper, but it's still way too dim, so I'm sure the high voltage is too low now. Yeah, back down to 5.5. So man, this thing is really sensitive to these tubes. So I will now swap out just one or the other and try to isolate which is the best horizontal output tube and high voltage rectifier. Now I can tell you, all of these tubes tests go to my tube tester. I already weeded through these, and I know that all these horizontal output tubes, all these high voltage rectifiers, they all test good. And I've heard time and time again from guys, the only true test is in a set. I agree, but I've never encountered a set that was so sensitive to tubes as this set. Alright, new old stock GE 1B3 high voltage rectifier, new old stock RCA 6BG6G horizontal output tube, and I went through about half a dozen 5V4s. Don't have any new old stock, but this is the best one I found out of the lot. And here we are. A horrible noise is the best sound I can get right now. And we are up to a little over 8,000 volts. I notice that the high voltage varies a bit depending on the brightness on the screen. So right now there's a lot of bright stuff going on, a drop. Now it gets darker, high voltage goes up a bit. Now I recall reading, now that there's quite a bit of brightness, went below 8. So I recall reading that is kind of typical. I'm going to turn the brightness way down on the CRT. So I would expect it to be more stable now. Ah, well over 9,000 volts too. Huh, how about that? So, I think this may very well be operating within the correct range now. And that high voltage just varies a bit depending on the brightness of the scene. Because the brighter the scene, the more current draw, and these high voltage circuits don't put out a whole lot of current, so I guess it droops a bit. Now, a couple other things of note. As I've gotten the high voltage to be higher and higher, the width has increased more and more, so now it's actually, I think, maybe a little bit too wide. Or maybe not. The mask on the CRT is a bit of a rounded rectangle, so might be okay just the way it is. But another issue is that this is maximum height right now. And I don't like to have controls at their maximum, and even so the linearity's off, and I don't think it's quite high enough, so there's a little bit of tinkering I'm going to need to do on the height. I just hopped onto eBay for the heck of it to see what a new old stock 5v4G might be going for these days, and I am quite surprised. I guess the quote audiophiles unquote have latched onto these. I've never seen these used as anything other than damper tubes in old TVs. I figured they'd be $1 or $2 each. Not $50 for a pair, or $80 for a Sylvania pair, or $21 for a Soviet knockoff. I mean, what the heck? Sure, you can get some used ones cheaper, $8. Or here's a new old stock Sylvania. Hey, bargain, only $15. So I'll keep poking around, but I think if I want to get these for a sane price, I'll just ask around the other collectors. Alright, $99 for a Telefunken 5v4. Awesome. If any of you guys know why these are so expensive or what these are used in, I'd like to know. Perhaps there are some amps out there that use them, but these are rectifiers. Come on. And not very good ones at that. 5U4 can handle a lot more current. I'm sure I'm not paying $75 for these. I'll just keep squeezing life out of the old used ones I've got now. One last thing I wanted to try before I touch anything else was to tack those mica caps back into the circuit. While doing so, I realized that my diagram I showed earlier was wrong. The mica cap goes between pins 6 and 8, so across one of the flyback secondary windings, not up to the primary. So here's what it did. Well, it definitely increased the width, so much so it's way too wide now. And let's see about the high voltage. I actually might have dropped a little, kill the brightness like I did before. And yeah, 8.7. I was more like 9.5 when that was out of the circuit, with the brightness turned all the way down. So I suspect somebody added that to both sets to increase the width, but as you saw, without that being in the circuit with these good fresh tubes in there, it's totally unnecessary. So, yeah, I don't know, maybe they added those because these tubes were weak or weren't well matched or whatever, and that was a cheap way to increase the width, even though the high voltage was still kind of low. I'll certainly be leaving them out. I'm double checking the tubes now just to verify if they are good or not. Again, I know I tested these before and they were okay. So this is the GE 5v4. It was in the set when I restored it a couple of years ago. And well, yeah, it's definitely in the replace range. It's not horrible, and for rectifier tubes often they can be kind of weak and work alright. This side of it's pretty bad though. This side not quite as much. So yeah, it is definitely bad. So I don't know if it went bad since I last checked it or what, but I swear this was good when I checked it before. Now let's see. Here's one of the other 5v4s. And this one came out of my 630 TS actually. I know that's working alright. One up a little bit longer. It looks like this one's pretty darn weak too. You can see it's got silver deposit above one of the sides as well. Not a guarantee that it's bad, but generally it means it's seen a bit of use. Yeah, man, this one's weak too. Huh. I know this came out of a working set. And this is the one that came out of the grungy GE810 that I just picked up. Alright, well this one's definitely good. But it doesn't work as well as the one that's in the set right now, which came out of one of my Admiral sets. So, yeah, for sure these are weak. I should probably just toss them, although I'm going to take one of these and pop them into one of my Admiral sets just to verify that these were working. No. I just popped the 5v4 that tested the worst, the RCA, into this Admiral set. And the picture's plenty bright, plenty of high voltage. But there's some major linearity issues. It's kind of cropped on the right and things are really stretched out on the left. So it's definitely not working right, but it is not affecting the high voltage. I misspoke a moment ago. The tube that I had just had in the set was the GE. This is the one that came with the 810. Now I've got the RCA tested so miserably. Similar results though. It's really not affecting the high voltage, just the width. And it's none of my business. If you want to dress up like a soldier and play Marine, that's up to you. And now here's the set with a good 5v4 in it. So having bad 5v4s, there definitely had an effect, but it was affecting things like the width and linearity, not so much the high voltage. Change the title of the book, that's all. So in the end, yeah, it seems like those 5v4s really are bad, and I'll have to just be more diligent with checking tubes in the future. And I also need to pick up some spares, I think. But I did a little research, and it turns out those 5v4s are indeed used in certain amplifiers, and the audiophile crowd has latched onto that. There are websites that talk about how certain 5v4s sound better than others, and it's really driven up the price, so I'm going to have to fight with those guys, I guess. So altogether, I tried 4 5v4s in this set. 2 produce very low high voltage and that test really bad. 1 is mediocre, and then there's a good one that's in there. Now, as I was saying earlier, I know I tested this GE for sure before I even tried powering this setup. When I first started this re-restoration, I checked all the tubes and it checked fine. And I was pretty darn sure that this RCA was good. So I'm wondering if they could have been damaged by this set. If you recall, there should have been a 560k ohm resistor in that damper circuit. And I had inadvertently put a 560 ohm in there. And for sure I used one of those tubes, and I think I might have used two of these tubes when I still had that wrong resistor value in there. So I wonder if that could have damaged these damper tubes. I don't know, but I'm glad that the mystery seems to have been solved and I can move on with finishing off this set. Okay, I put the flyback in that came with this set, dressed all the leads nice, and I fired the set back up. And now it's working just like I'd expect. Very bright picture, just like you should get with a nice strong 10FP4. And the brightness and contrast work just like I'd expect them to. And in case you're wondering, I now actually have a little bit too high of high voltage. It's supposed to be around 9,000 volts, so we're a little over, but I can tweak the drive control and cut that down a little bit. Don't want to overdrive the CRT and shorten its life. Alright, so next up I'm going to replace the control and then see where the vertical height is, and if it's still too short, troubleshoot that and then move on from there.